everyone. Monday night. How are you doing? Good to see everyone. Tonight is what is it? Our second edition of the
Yes.
Physicist? Yes, because last week time goes by quick. Well, hello, Claudia. How are you doing?
Hello, Wayne. I'm very well, thank you. And you?
Doing good, doing good. I have no complaints. It was a beautiful day today. And, I think anytime that we can learn, it is even a better day. So how's everything out in your part of the world?
Oh, it's fine. We've had quite a bit of rain, I think, and there's flooding going on here and there, but it's
Okay, so you're part of that, huh? Good
Yeah.
evening, everyone. How are y'all doing? Claudette, Wade, good to see everyone. Just to let everyone know, we're going to be doing a shortened version of the show tonight because what is it? 9 o'clock, it'd be 11 o'clock your time, 9 o'clock my time. I'm going to be filling in for Jennifer Collins over on her show, the Crypto Thinkers, on the Artist First Network. So Claudia and Scott Sion will be a guest on that interview. So if you'd like, and those of you who are the night owls or wherever the sun may be or not be in your part of the world, please join us for there because we'll have a great hour with Scott and with Claudia as well. So, Claudia, I wanted to bring to everyone's attention the following picture because I happen to think, give me 1 second here. I'm going to share this with everybody so everyone can see this. Do you see that?
Yes.
So this is a phenomenon that has taken place, and you can go over on Secure Team 10. You can go over into Mr. MBB3 channel, as well as you can go to, I think it's the Guardian. Claudia, this is a cloud that is, and it's strange, that has completely circumvented the globe.
Oh, my goodness.
There are eyewitness video shots from Norway of this cloud. It goes from horizon to horizon. You can't see the end of it, and it's a straight line.
Oh, my. Well, that's certainly not normal.
Well, you know what? I feel much better. So thank y'all. I'm glad y'all came in tonight. But you're right. It's not normal. I'm trying to. I love this. Well, I'm trying. So from your very quickly, I cannot think, number one, how this is possible. North-south.
It isn't possible unless some kind of artificial device gave rise to it. Basically, it's not possible as a natural mechanism. Let's put it that way. We do know we have chemtrail planes and so on up there, but it's impossible for them to make one that is this long because they disperse.
Yes.
So, and I don't think these planes travel fast enough to cause one this huge.
I don't think so either.
That wouldn't disperse at the end before the plane got to the other side. So this does not seem to be due to a chemtrail. Well, it may be, but it may be by a new type of spacecraft. I've noticed that they seem to be using these cloaked kind of ships. They don't seem to be planes. They seem to be using some kind of other ship, and they cloak them so that they look like planes.
Yep.
So they may have some very fast-moving craft doing this now, perhaps.
Well, what I don't understand, and we'll pull out of here because I have something else pulled up, is I'm going to do the screen share here so everyone can see where I'm going to go with this. So this is Earth Null School. This is a great tool. I'm getting the view, and I'm going to go from the polar point of view so everyone can see what I'm talking about. So this is at the 10 millibar, which is basically what, Claudia? I think it's
is this pressure?
yeah, but the 10 the pressure at that and I think it's 65, maybe it's 70,000 feet.
Oh, okay.
Okay,
yes.
So everyone can get an understanding of this. Now, here's my problem with that picture. Now, you explain to me how you can have anything going even in a near north-south direction when you have these kind of winds. And let's just get an idea of the speed of these winds. I'll put my cursor there. So that's 43.4 miles.
That's meters per second, I believe.
Meters per second. Let me get over here into the miles. There we go. So that's 97 miles an hour. We go over here. That's 111 miles an hour. Claudia, that's not possible to have anything going in a north-south. Let's go down to 700. This is about 10,000 feet. I just don't see how that's possible.
Well, these ones, at least in the southern hemisphere, are moving in the right direction, which is from west to east.
Except we have this one little anomaly here. So we have this issue over Africa as well, and I can actually zoom in on that so people can see what we're dealing with here.
Yeah,
look at that.
Very strange things are happening to the jet stream. I think we have two things happening with the jet streams. First of all, the jet stream is fed by the ionosphere. Everything that happens inside the atmosphere, all the storm systems, is fed by the ionosphere. And what usually charges the ionosphere is the solar wind and therefore the sun.
Correct.
So if we have solar storms, CMEs, and so on, we can expect to have more severe storms and crazy things happening to the jet streams. But the sun, as you know, is not that active, or at least they're not showing us that it is active. We do have coronal holes, and the fast stream will feed the ionosphere as well.
Do you see this headline? Or can you see that?
Yes, aghast. Yes. Scientists. Because the weather is getting extremely severe. Okay. And I have actually just written an article where I talked a little bit about this. And the fact, there you can see what's happening with the North Pole. And partly, I think what's happening with the North Pole is due to crustal displacement, in that the North Pole is no longer where the geographic North Pole is, at least not in that region anymore. It has moved towards Siberia.
Interesting.
Yes. And
they talk about that here.
Yes. So I believe we've had a crustal displacement that has changed things. But the other thing that's happening is that our ionosphere seems to be extremely ionized. In other words, very high energy coming from our ionosphere that is causing extreme weather on the surface in the atmosphere. Now, where is that coming from? That comes from the fact that I think we may have captured another moon with an elliptical orbit that's causing the crustal displacement. And that moon would, especially with an elliptical orbit charge the ionosphere. We have all these stellar cores that have come in. They have most likely brought planets with them. The stellar cores themselves are attracted to the sun, so they're very likely to stay very close to the sun. But the planets and moons, yes, this is where I talk about the magnetic reversal, were most likely captured by planets in the solar system. We know that Jupiter has gone from 16 moons to 69 in just a few years.
Now, see, I don't think people know that.
Yeah.
That's remarkable. Where are they coming from?
Exactly. So they have to have been brought in by all these stars. These are stars. So they most likely have planets and moons as well. So here I talk about the magnetic reversal we seem to be having. And that is, you can see there where the North Pole has moved in 50 years from North Canada towards Russia, and it's accelerated so that in the last 10 years, it moved half the distance that it had moved in the 50. So that shows an acceleration in its motion towards Russia. But it's moving in a single direction. It's not moving around from place to place, east of that, west of that, south, then north. No. It's moving in a single direction. And that's what made me realize that this has to be due to an object that keeps causing a crustal displacement in the same direction. And that could only be due to an object in orbit around the Earth.
What I did not know, Claudia, and I'm just now picking, and I've looked at this. I've done programs on this. I didn't realize that when we take a line, let's say a demarcation line of, in this case, where we have a north-south direction, this would then be an east-west equalizer, right?
Mm-hmm.
It's crossed over. Now,
yeah, no. It hasn't crossed over yet. It's still where the red arrow saying
right here. So it's right here.
Yeah, it's still there.
Okay.
So
but this is where it's heading.
It's heading that way. It's
Good,
heading towards Russia.
Okay. So let me rephrase my point then. Then my next question, instead of a statement, would be a question.
Mm-hmm.
When it crosses this demarcation line, what happens? I mean,
it's not that it will change anything dramatically, except that the United States is basically moving towards the equator.
Okay, there you go. I mean,
the new equator. You know, this is why the weather is going so crazy, and why the North Pole region is no longer really at the North Pole, and it's getting more sunlight. But that's not the only reason.
Okay.
The other reason is that it's ocean, and the oceans on Earth are warming up dramatically. And there you can see the shift. And you can see that since 1980, the shift has increased dramatically. I think in the year 2000, the pole moved by 70 kilometers. So this has been quite dramatically in recent years. And that, again, shows to me that this is possibly something like the Earth capturing a moon, a second moon.
When we're seeing these continued increments of 10 here on these kilometers per year, right?
Mm-hmm.
When I'm looking at this is exponential.
Yeah.
If you look over from a geological timeline.
Yes. The thing is, it moved slightly before then, that there was something still causing some kind of impact. But don't forget, we do have a moon, and we have the solar wind that may cause some kind of small anomalies. But the thing is, the poles used to shift backwards and forwards. So it would move in one direction, then it would move in another. It wouldn't move in a single direction like it has been doing for the past 50 years. That shows that something else, and it's accelerating, moving faster and faster. So to me, that means there's something that has changed with the Earth. And it isn't the only thing that has changed. We have tidal events that can only be answered. Here, I'd like to say, first of all, the way the standard model for explains the way the magnetic field of the Earth is produced is due to convection currents taking heat from the inner core towards the outer core. And these currents then powered by the gravitational field and the rotation of the Earth cause these spiraling currents, and that's supposed to produce the magnetic field. But that is ridiculous because, first of all, convection currents are like currents that you produce when you have a pot of boiling water on the stove. And these are not stable. They will shift around from place to place. If you put something bobbing on the water, it will move around. It will not stay stable. So the magnetic field would change from day to day if this was the case. Also, don't forget that Venus is much hotter on the inside, is much more volcanically active than the Earth. And yet it has no magnetic field. So if it was due to heat, due to these convection currents, we would expect Venus to have a much stronger magnetic field than Earth, but it has no magnetic field. So that's not what's producing the magnetic field. And because the Earth's magnetic field is reasonably stable, at least it has been for thousands of years, that shows that it's actually due mostly to the fact that the Earth is a permanent magnet. And the way you produce a permanent magnet is, the core is mainly iron and nickel. You take a piece of iron, you heat it, you place it inside a permanent magnetic field, you allow it to cool down below the Curie point, in which case the field, when it's cooled down below that level, the material becomes permanently magnetized. So it has a permanent magnetic field. It's now a magnet. So I believe this is actually what happened with the Earth. The inner core has its own magnetic field. It's permanent. It's like a permanent magnet. And then the outer core that is solid, not the outer core, the crust and the mantle are solid. The outer core is liquid. And these have permanent magnets, or permanent magnet as well. And the two superimpose on each other produce the basic magnetic field of the Earth. That's the inner core there, yes. So that is actually a permanent magnet. And then the crust has iron in it as well, so permanently magnetized metals in it, and that produces the rest of the permanent magnet. Now, that's not all that the Earth has to produce its magnetic field. The solar wind and the solar particles also impact it, but they align themselves to the permanent magnetic field. So they will have the same north pole as the permanent magnetic field. It will not affect the direction. So here I just mentioned that we do not need an object to have a liquid core in order to produce a magnetic field, because the stellar cores are solid. They have solid surfaces. They have solid material on these surfaces, and yet they certainly produce magnetic fields.
Would gravity be impacted? I guess, I've always, since we can't define what gravity is, as you were just talking, it would seem to me that the greater the intensity of the magnetic field, the greater the gravity would be felt. Am I wrong on that? I'm just throwing that out there.
Initially, I started thinking, because of the way these objects interact with the sun, that the gravitational field had to be electrical in nature.
It would, wouldn't it?
Yeah, but I've reached the conclusion that that's not actually possible, because, as I mentioned before, the signaling problem, the electric interaction signal travels at the speed of light. Okay. And gravity is instantaneous. So one cannot be related to the other. I mean, electrical force cannot cause the gravitational field. They have to be separate forces, but the electrical is much stronger and therefore will have a stronger effect. So yeah, this diagram actually explains what causes the magnetic field. And what we have is the gray arrow is the magnetic field of the core, the black sphere at the center. The purple arrow is the magnetic field of the outer crust and upper mantle, the purple arrow. The two together produce the total permanent magnetic field of the Earth. So if you add the two, you get the green arrow. And that's the Earth's magnetic field orientation. Those are the magnetic axis. And then the black dot is where the North Pole is.
Okay.
Okay. So this means that if you change where that magnetic pole is, you have to change the orientation of the green arrow. You cannot change the gray, but you can change the purple by a crustal displacement. If you displace the brown, which is the crust and the upper mantle, so that it rotates with respect to the core, then the orientation of the purple arrow changes, and then the overall orientation of the magnetic field, which is represented by the green arrow, will change. So you need the crustal displacement to change that.
I read back in the, I guess it was 2002, I was doing research on a book, and there was a theory postulated by a French geologist working. He was a professor at the Louvre, I guess, the university there. Mm-hmm. Anyway, he said that there was evidence that in Earth's past, recent past, that there is what he called sudden dramatic shift of the plates. Mm-hmm. And where the common standard model says that these movements take time, mm-hmm. that they when there is an occasion, it's going to be localized. Mm-hmm. He said that there was evidence of something in recent past is, could be as 10 million, 100 million years ago, mm-hmm. a shift, Claudia, of the whole mantle.
Yes.
Now, would that be indicative of a magnetic pole flip or a...
That's exactly what a crustal displacement is.
Okay,
as the mantle, the upper mantle and the crust move with respect to the core. They basically lose connection to the core because there is a fluid between them.
Right in here, right?
Yeah. So the red here is the liquid part, the outer core. And a crustal displacement means that the brown layer, the outer layer, loses contact with the black core because there's a fluid in between them. And what actually causes that is a tidal wave created by a fast-moving object moving fast across the Earth's surface. It causes a tidal wave. That tidal wave overcomes the friction between the brown outer layer and the red, which is liquid, so that the brown layer rotates freely and disconnected from the core. And that's a crustal displacement.
Wow. Yeah. Now I can see this because basically it would be like, you would almost have a graphite layer that is now you lose the cohesion.
That's right.
And I have a person who is tutoring me on the side, and and he's right. I think that he says that modern physics does not take consideration of the cohesion factor. That cohesion is actually more of a dynamic role than gravity. Mm-hmm. I mean, that's what he's postulating.
Yeah, I actually, in my latest articles, I have written about the fact that both Earth and Mars show evidence of something dramatic having happened a few thousand years ago, not long ago at all. Mars seems to have lost its oceans, its water, and most of its atmosphere about 4,000 years ago.
That's recent.
Yeah, extremely recent. And the way we know this is because the ocean basins and the river, the outlines of riverbeds are still visible, clearly visible on the Martian surface. And if it had happened millions of years ago, it would have eroded away. So it could only have happened about 4,000 years ago.
Very interesting, Claudia. Well done. Well done.
Yeah. I've gotten quite a bit of help from James McCanney because I've read his book, and I picked up a lot of ideas from his book, plus my own thinking behind it. You know, I've been writing articles about those ideas. And that's one of the things that I think has happened. And it's caused mostly by comets. Yes. Okay, so here what you see is the external part of what produces the Earth's magnetic field. And these are actually particles that come in the solar wind, and they produce currents in the ionosphere. This is what the currents look like. The red ones are positive ion currents, and they flow west to east. And along the equator, you have the electron current, which flows in the opposite direction from east to west. Now, these, as you can see, are very close to the jet streams. These are what produce the jet streams
I was going to say.
In the atmosphere below. They are connected. And if you get more currents occurring in the ionosphere, of course, you are going to affect the jet stream. Also, this is what produces these stripes on a lot of the celestial bodies in the solar system, including the stellar cores. They often have, we have observed them to have stripes. And the stripes are produced by different layers of material flowing at different velocities and often in opposite directions.
But it would be indicative of an electrical current.
Yes, just about everything is electrical. Don't forget, the electrical current is much stronger than gravity. I'm not saying gravity doesn't exist, but it's much stronger. And I've reached the conclusion recently that the reason why these objects do not seem to interact gravitationally with the sun is because they have very high charge to mass ratios, which causes the gravitational interaction to seem extremely weak because of the repulsion caused by the electric interaction.
Interesting.
Yeah.
Okay, I see that.
Yeah. Now, what we see here, this is actually in the outer core. You see the black is the inner core of the Earth. The red is the outer core. It's filled with molten rock, basically. That's why it's red. It's the same color as magma. And we have induced currents in it. And the way I draw the currents is not at all the way that those who believe in these convection currents would draw them. They actually are forming loops around the core. And these loops would produce magnetic fields. These are electric currents. They would produce a magnetic field that would align with the Earth's permanent magnetic field. So this is why anything, even though electric currents that are induced due to whatever's happening in the ionosphere will be aligned with the Earth's permanent magnetic field. That's why this is not likely to cause any shifting of the poles. Everything would align to that same North Pole direction.
Okay, so I have a question.
Mm-hmm.
So if a body, let's say a moon, a planet, exoplanet, etc., that if it had a low magnetic field, and basically I'm using the word as well, a low electrical field, Would it necessarily have to be solid? And if it even passed by a larger object, its effect on the larger object would be de minimis in its impact. Right, or am I right or wrong? Am I thinking?
Okay, so it doesn't have to have a liquid layer to have a magnetic field. That's the first thing.
Okay.
So it can be just a solid object. The stellar core seem to be completely solid, and yet they have a magnetic field. And then the other thing is that magnetic fields I've discovered are actually secondary forces. The primary force is the electric field.
Okay.
And we produce a magnetic field whenever an electric field moves. It has to move, or in other words, we have to have a current in order to have a magnetic field.
Okay.
If the charge doesn't move, there's no current, then we'll have an electric field, no magnetic field. Now, objects interact mostly through the electric field because the solar system acts like a capacitor with the sun in the center, which is the negative part, and the sun acts like an atom. In other words, it has a potential that causes it to separate charge. So the inner sun is positive and the electrons move to the outside. And this happens to every single object in space, that the inner part is positive, and then around it there will always be electrons that makes the outside layer of the object negative. But this is the same that happens everywhere in the universe. Don't forget, an atom is like that. The atom has protons in the center and electrons on the outside.
Wow.
Stars do the same thing. Stars are actually super atoms.
And the sun, even as far as its heliosphere that really goes way out there, would be emitting these electrons, this field as well, right?
Yes, what happens is the sun produces ions, and these ions, whenever we have some kind of discharge in the sun, there are ions and electrons that are separate. There's a kind of plasma, but the ions are ejected because the center of the sun is positive, and they are accelerated past the electrons and into outer space. Whilst the electrons, because they are repelled by the outer electrons in the corona, stay behind. So there's a current of the solar wind is mainly positive ions that are going out to the outside of the solar system, and they are adding to a nebula cloud that seems to form around every star.
Wow.
Yeah. And then as comets come in, they produce a tail so that the ions from the nebula cloud come in towards the comet nucleus, producing the tail. And then electrons come from the surface of the sun towards the comet, producing a negative tail. I have written some articles on this. I'll send them to you. Maybe we can talk about
I'd love to. I'd love to.
Yeah.
Now,
so here we see the crustal displacement actually occurring.
Yeah. And we're seeing this right now.
Yes.
Down in South America, down in Africa.
Exactly.
I don't know, by the way, what's going on in Papua New Guinea, but let me see. Yep. Between shows, go and check out what's happening in New Guinea. Something is going on there, Claudia.
Yes. I believe so, that the kind of damage that seems to have occurred with a 7.5 earthquake does not make any sense.
And are you ready for this? Counting since that 7.5, nearly 19 5.0 or greater aftershocks.
Mm-hmm.
That's just off the scale.
It is. And the thing is, I've been noticing that we have sinkholes. We have the earth opening up. Don't forget that 20 years ago, we were taught that it's impossible to have any fast changes on the face of the earth like we are seeing now.
Correct.
We are seeing whole mountains collapse. Sinkholes appear overnight, huge sinkholes. That it was not supposed to happen. This is happening because something is affecting our planet. And it's not just the sun and the stellar cores. I believe that what we are seeing, these tidal events, have to be due to an object closely approaching the Earth. So I have placed this moon in a very elliptical orbit so that at perihelion, when it comes very close to the Earth, it would cause a shift. It would cause tidal events, and it will cause a tidal wave in the liquid part of the inner Earth, and that will cause crustal displacements each time that it goes through perihelion.
Now, here, you said that the Earth has acquired a new moon.
Yes. This is not our moon. This is a new moon. Because, well, it is possible that our moon's orbit has been changed, but I doubt that it has changed so that it's coming this close to Earth. This is more likely, I think, to be due to a newly acquired moon.
Well, listen, if Jupiter has collected 9. I think, Claudia, what I'm learning, particularly with what you're teaching and with the other guests that we've had on here, is that we have to eliminate the limitations of what we think we know of what space, the solar system is. We so often want to rebuke the scientist. And by saying NASA, never a straight answer, and we go through all of this rigmarole. But at the very same time, then we want to fall back on their science. When, in fact, I like exactly what you're saying here. We're still defining what's going on, even in our own Earth.
Yeah, well, NASA is to blame for the fact that we have just about no data to work with.
This is true.
What they do is they never show us the raw data.
That's true.
What they do is they take the data, they interpret the data themselves according to their theories, and then they give us their interpretation. And often the data doesn't fit their theory. So what they do is they put in some parameter, some way of changing the data so that it fits the theory. So in other words, we are just getting their theories and they're hiding the real data. They are hiding what's really happening. If there is a new moon, they will never tell us there is a new moon. We have to figure that out for ourselves.
Yep.
A lot of people are reporting that our moon is rising at very different times. And this could be two things. We could be seeing two moons, or our moon, if we have a new moon, our moon's own orbit would most likely be perturbed.
Well, I know right now, before we came in, I took my measurements. We are off 6 degrees from where it was yesterday.
Right.
That's fact.
You see, people are reporting. I know, I've heard this over and over and over again. The moon is not acting like it should.
No, in fact, it acts as though it's stoned because you can watch it. I mean, I know exactly. I take the measurements as it's coming up, and I'm looking at it now and I'm going, well, no, that's odd. But anyway, yeah. So how would we begin to know this second moon? How would we begin to see the effects of that?
Well, that's the thing. I
need to pull down again here.
Because of the shift in the poles, okay, that we are seeing, we have definite data about that.
Yes, we do.
And because I can explain how the Earth's magnetic field cannot be changing just like that It's just impossible. It cannot change like that due to something happening inside the Earth. It has to be happening due to something outside the Earth, in outer space. That's the only way that this can happen. And the only possible way that we can have these changes, incremental changes in the same direction and an acceleration, that, as far as I know, can only be explained by either our moon having changed its orbit dramatically or us having acquired a new moon.
Wow. That would begin to have a cause and effect going back to when we started this conversation, Claudia, about the Earth and the weather changes.
Exactly, because this moon, because everything is electrical, would ionize our ionosphere, so it will cause severe weather changes. It would cause earthquakes in two ways, through the electrical interaction and through the gravitational interaction. It would increase volcanic activity. It may cause the whole Earth to shake to the point that it just starts breaking. You know that if you take a building, you shake it a couple of times, you may not see the damage, but there is a damage. There are little cracks in it. So then you give it a little jolt and it comes down. And this is possibly what's happening with these mountains collapsing, with these sinkholes just appearing overnight.
Well, you know, when you just take a look on this of the Earth, Claudia, you can see very clearly that that what we see today, we can see where it came from yesterday. And very clear that you can see that South America at one time was joined to Africa. You can see where the United States came right in over here by Europe, up around Spain. I keep on getting reports, and I'm the first one, folks. Something's going on with New Zealand, Claudia. It seems like every time I get a picture of where New Zealand is, it seems to be going further and further away from Australia. And Australia now seems to be running into New Guinea.
Yeah, well, to tell you the truth, with the kind of earthquake activity we're getting, and don't forget USGS is hiding most of it. So, and I also believe they have managed to make earthquakes seem less strong. And they do that, I think, through the way they optimize their systems. They can change it at any time. They probably have been changing it for a few years. You know, the way the seismic stations are calibrated. Yep. It's changed over the years, the system for calibration, and a calibration can reset basically the strength of an earthquake. And if you're starting to see the kind of damage that we're seeing with a 7.5 magnitude earthquake, I know that it was quite a shallow earthquake, but even so, we have the mountains collapsing. This is ridiculous. It's not supposed to happen.
Yeah, and I'm just, you know, we're obviously getting some effect from, obviously, I think this coronal hole stream that's coming in now. Yeah. It's just now showing up on ACE. But what we have seen here, though, for the longest periods, what I'm seeing is this weakening sun. I mean, it has gone flatline all the way across the board. And in what do we have now? For, I think it was 8-9 days, we had a completely spotless disk. So I'm just looking at the measurements that we can actually see.
Yeah, but don't forget, the sun may be placid, but we have other stars in the solar system now that have rejuvenated and are possibly having their own CMEs and solar winds.
Oh, good point. Thank you, teacher. See?
And that they not.
That's why you got the PhD.
What they're hiding from us with everything they have. They will change images. They will add things to images. They will manipulate the images. They are hiding this. They are also hiding data regarding comets. Hale-Bopp seems to have been about the size of the moon, a huge comet.
Yep.
And that's when they started hiding these things, because they started seeing that comets could be cataclysmic. if they came close to Earth.
Yeah. Can you see that, Claudia? Do you have the sun up there?
Yes.
Yeah.
No sunspots.
Nothing. Nothing, folks.
Mm-hmm.
This is why I have such respect for Dr. Albers. When we met years ago and she was writing her papers on this weakening sun, Claudia, there was a lot of ridicule, but when you see this, and we're seeing this more and more, and yes, we know that we're in a grand solar minimum. We get that. We know that. But again, what we're seeing, and let's just go. If anyone would look at the sun, I'm going to pull it back over here, and I want to pull up the, see if I can find SOHO. The fact that the coronal holes, I'm seeing them all the time now. When you look at, I think it's 197 angstroms. It's getting scary. I mean, I'm seeing this opening disk, Claudia.
Mm-hmm. I said this months ago that the sun seems to be turning into one large coronal hole. And I believe we are still at least 2 years away from where the solar minimum is supposed to happen. And the sun has reached solar minimum activity already. In fact, it did in December. And so we can see the sun is definitely weakening. And this is because these objects are draining the sun. These are stars that spent their own ability to produce light, and they came to the sun and they draining the sun's own material that it uses to produce light, its own energy. And this is why we having these. You look at it.
I mean, it's
one big coronal hole. There's hardly anything left.
If this was a cancer, this patient is terminal.
It is exactly, and this is what we see. I mean, if you look at it in soft X-rays, low energy X-rays, you can see the effect even more.
Yep. I just have this one pulled up. And
that's fine. We can see it's dark. There are holes everywhere.
Just everywhere, folks. And, this is just, Claudia, I know we have a very astute group here. We all know that this is just raw, unshaded radiation coming at us.
Yes, that's right. So we have fast solar wind coming out from these holes, and they are actually connecting to these stellar cores. They seem to be connecting there. But basically, the sun is losing particles that it uses to emit light. And it's losing these particles to the stellar cores. They are absorbing these particles. And I think the sun has been invaded by stars before. I believe now that Neptune, the gas giants, are actually all small stars. They are actually producing fusion in their own atmospheres like the sun does. And these have probably come into the solar system many years ago, maybe thousands and thousands or even millions of years ago. They probably came in, and if they were old stars, they may have gone through this process, rejuvenated, and then settled into orbits. But now we have a system. It's a huge system. It's a lot of objects. And the sun is not coping. Basically, it's dying.
All the indications, and I know some people say that that's extreme, but we take for granted the sun has always been there. It's never going to change. And next week, we definitely will get into the sun simulators. But it's changing. And it's changing for the worse. I mean, I look at the radiation reports just to give people an idea of the type of, and I'm just trying to pull it up now, that where we can actually pull up the radiation reports on a daily basis. And we know that we're getting bombarded with it.
Yes.
Yeah.
Yeah. But this may be because we have all these other objects that are emitting radiation, possibly different from the sun's radiation. And this means that the Earth is getting bombarded with this radiation. It's coming in. We are getting a lot more cosmic rays.
Mm-hmm.
We cannot forget that I actually believe that whenever we have solar flares, cosmic rays are produced. And all these stars will be having their own solar flares.
Oh, yeah. That would make sense, wouldn't it?
So all of these objects are creating cosmic rays. And the Earth is getting bombarded with cosmic rays from inside the solar system. The sun may be allowing more cosmic rays from outside as well, but I think the major problem is what's happening inside the solar system. We're getting bombarded with cosmic rays, cosmic radiation. They're producing their own ultraviolet radiation, so the Earth will be bombarded from that as well. Plus, the simulator we have in space seems to be producing its own ultraviolet radiation as well.
Yes. Yeah. And things are changing, folks. That's all I can tell you. They're changing. Claudia, we've gone the whole hour.
Oh my goodness.
This is just great. Folks, I hope you're enjoying this as much as I am. I feel like I'm getting a free education. I just got to tell you. So I think we can all do our part by going over on Planet X Physicist, subscribe to Claudia, and watch her videos and learn. You know, you may not agree, but as I always say, well, just bring your PhD parchment and, you know, you can go ahead and talk to her because I'm just a layman. I just, you know, I listen because I respect, as I told you, Claudia, years ago, that the discipline of the mind in order to go through the process, through the system to get that doctoral degree is not an easy feat.
Yeah, I used to tell my students that you may be learning theories that may not be correct, but it's not about the content. It's about learning to think in a certain way. That's what a physicist does. A physicist is trying to think in a certain way in order to come up with explanations and models and solve problems. Wow. That's what I was training my students to do. It's not so much the content. Even if the theories are wrong, what's important is that you are learning to think like a physicist.
I love this because you know what you just taught me just right there is the fact that free thinking, and yes, many theories are proven wrong. We know that. But if it's not for the fact that they were proven wrong, we wouldn't know the ones that were proven right. Mm-hmm. Correct?
That's right.
I mean, the way I looked at it when I was going through school, anytime that I got a B, you know, it told me that I needed to get back and find out what was wrong in my thinking. Mm-hmm. And then I started learning to kiss the teacher's butt. But anyway.
Sometimes you learn more from failing than from winning.
Yeah, you absolutely do. And, you know, I remember I saw Michael Jordan speak at an event, and, you know, he got up there and he said, you know, he said, I have let my teammates down. He said, every time I go out to play the game, he says, I tell them I'm going to let you down at least 70% of the time. You know, but, you know, the guys we all remember seeing the man play. Well, yeah. Dr. Albers, it has been a tremendous hour. Thank you. I love this. You know, I think this is going to be a program that's going to gain in popularity. I mean, seriously, folks, do you know what a class would cost us? We'd all be passing the plate. Well, Claudia, I will see you next week, if not sooner. And I'll see you in the next hour. Folks, if you get the chance, go over to the Artists First Network. Click on Crypto Thinkers. That's Jennifer Collins, and you'll hear us in about an hour. Now, this Friday night, I have Lisa Bennett coming on. Folks, this is going to be fun. She is probably one of the best experts that I know in the Akashic record. And this is going to be a fun program. So that's this Friday, and we'll probably see you before then. Claudia, I will see you in a little bit.
Wayne, thank you very much.
Thank you. Everyone, be kind to yourselves. Thank you for coming in. Thank you, moderators. Appreciate you. Y'all just did so great. Thank you for everyone for being so respectful. We learn when we respect one another. We may not agree, but we can always use respect with our words. And this is what people love about you folks. They love it. Every person that's been on here as a guest has said, this group is different. So congratulations, folks. I appreciate you all of it. All right, folks, we'll see you real soon. All right, bye-bye.